This is Sam, in a little bit of a follow-up, video essay. One or two things I forgot to talk about that's relevant is the double slit experiment, where invariably the results are like an interference pattern. No matter what they use, whether it's electrons, protons, or photons, single particles at a time, single photons at a time, like detectable by a photomultiplier, as single photons at a time through a double slit arrangement, or a different sized one for electrons and different sized one for protons, and the results are always the same, like an interference pattern, which only makes sense from their standpoint. The thing is, from the conventional probabilistic standpoint, but there's other evidence that seems to conflict with that as well, which makes it seem like we're both wrong, convention and me. For instance, proton decay, they've never been able to find an instance or evidence thereof. And there's a thing in science, in physics, called neutrinoless double beta decay, which they have never been able to observe, ever. Those two instances, those two data points, fly in the face of the double slit data. How it does that is because in their framework, every single particle, whether we call it stable or not, should at some point decay or change identity at least. So they look for proton oscillation, they look for neutron oscillation of different kinds, neutrons with their mirror particles, and neutrons with antineutrons, and protons with antiprotons, and possibly even protons with their mirror versions. Conventional science is looking for alternating states of existence for these particles, because those alternating states fit their notions. It's a little hard to observe things that, let's say that they were patently stable and patently do not oscillate in states the way that neutrinos supposedly do. What if protons don't oscillate in state between their mirror partners or their antiversions? What if neutrons do not oscillate between their mirror versions or their anti-partners? Like I said, the data is currently indicating that we're both wrong. The current data looks like we're both wrong. When I say we're both wrong, the probabilistic perspective, meaning that single particles supposedly are constantly changing identities, oscillating between one form and another, or the local deterministic perspective that says, no, they are what they are, they've always been what they are, and that they're always going to be what they are. Protons are protons are protons, electrons are electrons are electrons, neutrinos are neutrinos are neutrinos. Now, according to convention, neutrinos oscillate between three different states of the three different so-called flavors of neutrinos. The electron neutrino, the mu and the tau. Supposedly, those neutrinos constantly oscillate between, and I believe that several individuals were awarded a recent Nobel Prize in physics because of that theory, because of that framework, explaining the so-called solar neutrino deficit. So my sarcasm in the essay, the previous essay, it's like one comedian making fun of another comedian, kind of like that. The thing is, what if we're both wrong? What if convention is wrong about assuming that all particles are oscillating between states? Because the evidence right now doesn't indicate, we have not found, we've looked and looked for many, many years for proton decay. Not a single isolated proton, but a proton within a nucleus, like with a high likelihood of exhibiting proton decay. And they have not found it. As well as they have not found that, the conjectured, from my point of view, the conjectured neutrinoless double beta decay, which according to their framework, according to Feynman diagrams and quantum field theory, it should happen, but it doesn't seem to happen the way it should, the way they expect it to. So there's the data is inconclusive. According to Bell's theorem, which has been refuted at least three times, local realism is dead. According to Bell's theorem, he's an English mathematical physicist. It's quite famous in physics. The essence of that theorem, that statement, or that what I call conjecture, is that local realism is impossible. Which, as far to my knowledge, has been disproven at least 3 times. The thing is local realism has difficulty explaining the double slit arrangement and the outcome, repeated outcome with different types of particles, and just as well as convention has extreme difficulty for explaining no neutrinoless double beta decay and no proton decay. So there's confusing, the data right now is inconclusive about local realism versus not. Anyway, this is Sam, also known as Salvatore, signing off for now.